think we are live now. Okay, so now we go to our first half of the lecture for today. We're going to discuss geochemical exploration methods. Why did I skip geophysical exploration methods? Because it's for you to discuss to your classmates through your presentation, the recorded presentation that you're supposed to do. Okay, and I hope that you are gaining traction on how you're planning to tackle those geophysical methods that are assigned to you. Okay, so when you say geochemical prospecting and exploration, I think we already defined this nung first lecture. Again, the focus here is on the word chemical. You're looking at the concentrations of chemical components in surface materials. And there are so many surface materials, not only the rock, the soil, even living things, even humans and animals, and even plants, and even the air, okay? So basically, you're getting the concentrations of metallic minerals, or even sometimes yung non-metallic, but this is medyo rare, no? Mas madalas na we're looking for metallic concentrations in many of these. And we do sampling, when we do that, okay? This is performed by systematic measurements of one or more chemical parameters, and many of these samples are actually in traces. Ibig sabihin, hindi siya marami. We're basically parang detectives, no, na getting crumbs of information from the crust, or at least from the surface of the earth, and maybe even a bit on the subsurface. Okay, so the geochemical cycle, okay, according to Rose and other authors, they describe the geochemical cycle as a dynamic system, okay, wherein the earth materials are following, or at least changing in form, in composition, okay, and these are governed by many, many different processes. If you actually look at the processes here, many of the things here are actually quite familiar to you, like metamorphism, you have erosion, you have sedimentation. What are these steps? These are the same stages, or at least the phases of your rock cycle, the activity that I've been asking you to do. Why did I ask you to do that activity? Because these are the same processes, these are the same activities that will give you clue on how the ore, or how ore bodies are formed, and as well as in the context of the geochemical prospecting and exploration, how the different remnants, or how the different traces of these minerals or anomalies can be spread out to a certain area, which gives you a clue where now to find the valuable minerals that you're looking for. Okay, so I hope madali lang siyang magets for you. If, by the way, again, as I remind always, if you have questions, if you have reactions that you would want to show to the class, if you would have other thoughts, comments, please use the chat. Okay, so under these topics, you would have two types of dispersion. When you say primary dispersion, nagkalat, no, or na-distribute or na-disseminate, ganyan. When you say primary dispersion, this is through the aqueous fluids, and this is expressed in alteration and zoning. These should be familiar to you, because the aqueous fluids that are mentioned here are sort of, or at least the same fluids, hydrothermal fluids that we have talked in the past, okay? Medyo mas malaki lang yung sakop nito. Kasi yung mga fluids na yan, yung water, it flows in so many places, and even if it intersects or touches a hot igneous pluton, or at least an igneous intrusion, that water will react, and it will actually literally boil and spread out and then go to certain directions, okay? Now, when you say alteration, alter, from the word alter, nag-chemically change yung inyong bato from one form to another, okay? There are so many ways on how this could happen, okay? When you say zoning naman, there are zones, okay? There are areas wherein a certain mineral would actually form, and sometimes they would associate with other similar minerals. Sometimes you would see, more often than not, the minerals that you see in nature, hindi sila like lone or alone lang. madalas kapag nakakita ka ng isang mineral, that's a clue on what other minerals or what other metals you can find. And they usually have a relationship and ayun, meron silang ano association, assemblages. That's what I was thinking. May mga mineral assemblages, no? Okay, so how do you get a clue on primary dispersion? Of course, you look at the area, okay? So in this case, yung different colors, these show the relative, anong tawag dito, the relative abundance of certain minerals. In this case, masyadong maliit, no? Pero sulfates, kapag mas pink siya, mas mataas yung concentration. The more yellow it is, the less. Okay, ganun. And then this one, leakage patterns, okay? Alam naman natin ng rock ay, lalo na kapag may outcrop ka, when you say outcrop, kapag naka-expose siya sa air, tapos kita mo yung profile ng rock, no, it can also give you a clue, especially yung mga faults, yung mga folds, discontinuities, ito yung mga crack sa bato na nakikita natin, it could give you a clue kung saan kaya napupunta yung tubig or yung aqueous fluids na to. And also the wall rock patterns themselves, they would show, okay, even the plain color of the layer of the sediments, the colors, the slight variation in colors of the rock, host rock, or at least the bedrock would already show you primary dispersion or give you clues on this. Okay? Now, this is another example. Sino magaling sa geography? Anong country ito? Would you know? Kung anong country ito? Yeah, maybe you can try in the chat. Mukhang wala. I'm not sure. Okay, anyways, the colors here would show the copper levels in certain places in this map. Okay, this is actually the northern part of the United Kingdom. Okay, UK. And it would show you how much copper there is in some of the parts there. So obviously in this red parts, there's a lot of copper. In terms of percentile and ppm, parts per million. So what does that mean? If there's a lot of copper there, then that means most often than not, okay, there's an ore body nearby, or at least the sediments were deposited. Pero ganun pa rin, kung may sediments na na-deposit, ibig sabihin may malapit pa rin na source or anomaly or ore body. Okay? Now, there's another type of dispersion called secondary. Okay, kaya siya secondary kasi sumusunod siya after the primary dispersion. This one refers to the dispersed remnants of mineralization caused by processes that are related to chemical and physical weathering. If you would remember weathering, the definition of weathering in your earth science, it's the physical breakdown or physical or chemical, depende kung ano, no, the breakdown of your rock and other materials similar to that. Okay? So, kapag na-breakdown na yung rock, maaring mag-disperse lalo yung ano na yon, yung mga samples or at least the remnants, the minerals, the metals content that you can find in those rocks to, number one, to rivers, okay, to streams, river systems, okay. So, and in this example, sa mga channels na to, nagsasample sila, okay. Kumukuha sila ng samples, tapos yun yung nagbibigay sa kanila ng clue, okay. Parang nag-iiwan nga ng crumbs, nag-iiwan ng clues yung ano, no, yung kung saan ba galing, saan papunta, ano yung direction papunta dun sa mataas yung concentration ng mga elements or minerals or even metals na hinahanap ninyo. And then when you say dispersion halo, like it's a certain area wherein circular siya, okay, and then that's where you can see the area that has a lot of concentration of a certain mineral or a certain metal, whatever, ganyan. And usually, ang nasa gitna niyan ay yung exposed na part no ore. Like in this case, the gold ore is here in the, not really in the center, no, pero in the middle part. Okay? Kasi ito parang ellipsoid yung kanyang shape ng halo niya. Okay, this is another example. So, pansinin niyo dito yung mga dots, yan ay the size of the dots would indicate how large the concentration of the metal is. So what does that mean? What does that imply? Ibig sabihin nun, obviously, yung mga areas na malalaki yung dots, dun yung matataas na metal concentration. So dalawa lang ibig sabihin yan. Maaring dun na deposit yung through the sediments and through the water or whatever elements there are, yung mga hinahanap ninyong trace minerals, or pangalawa, nandun mismo sa may area na to, itong sinishade or minamark ko ngayon, maaring na dyan pala sa ilalim yan yung mismong ore body. And then this case nga, nandito pala daw siya dun sa star. Okay? So I think it makes sense naman na kapag may clue na malapit ka somewhere, tapos may nakikita kang something, hindi yun nanggaling sa malayo. Most likely, galing yun sa malapit, no? So I think that's logically sound naman. Okay. So next is, na-mention ito, yung physical dispersion or weathering. So just a review of sorts. Pag purely mechanical, ang mga agents of weathering, okay, that's physical. And then if you have difference in chemical composition and chemical changes, that's chemical dispersion or weathering. Ito, for example, this one here is called frost wedging. Bakit nabitak yung bato? Kasi may mga pumasok na water, tapos kita nyo may glacier dyan. So pag malamig, nag-expand ang water, so magka-crack yung bato. That's actually physical, okay? Ang chemical dito ay itong example na to sa, kita nyo yung nagbubutas-butas yung statue, and even this one, yung ating cave systems, okay? Yan ay more of chemical weathering. And those are the same processes that affect your geochemical cycle. Okay, now we do a lot of geochemical surveys, so I'll just show it all. You don't need to memorize these, but at least get an idea on what do they mean, especially mga naka-red, no? When you say geochemical, ito hindi ko alam for the longest time. Nung face-to-face pa, may natatawa pag sinasabi ko yung word na yan. I mean yung prefix na yan, no? It means soil. So ang study ng soil is actually called pedology. At hindi yung study ng bata. Iba yung pediatrician kasi. Anyways, nababother lang ako, no? So geochemical, ibig sabihin, you're looking into the soil. Anong meron sa soil na may clue ngayon sa geochemistry nung area na to, or at least nung hinahanap ninyong ore body. Next, consolidated weathered cover prospecting, lithogeochemical. Pag sabi namang litho, it means rock. So instead of soil, yung rock naman yung titingnan ninyo. Drift or till geochemical survey, ito mga terms ito dun sa mga sediments and other things that you will find. And then stream sediment, hydrogeochemical survey are both in water systems and river systems, no, or in other forms of water, bodies of water. Of course, you will see here vegetation, geobotany, biogeochemical, and even geozoological or geochemical. Isa pa yan. Pag sinasabi ko yan, natatawa din sila. Hindi ko alam. Sobrang yung iba ang immature, no? Anyway. Okay. Ayan. So, ano bang gusto ko sabihin? Na-distract tuloy ako. Okay, in these cases naman, you're looking into live creatures, and I just remembered one example, no? Kapag mataas ang cinnabar or mercury content sa isang lugar, kahit pa walang mining, sometimes the area, the people there would exhibit symptoms of what they call the Minamata disease. Kasi una to na-observe sa Japan way back 1950s ata or 1960s. Yung napansin nila, nagkakasakit yung mga tao, may mga symptoms siya na nag-iiba yung itsura ng mga tao, tapos napopoison sila basically with mercury, no? So that's in a way a clue also of for these geochemical surveys. Okay? Next is atmogeochemical, from the word itself, the air around you. And then electrogeochemical, you use probes, you use electrical properties. Okay, ganun na din yung sunod-sunod dito, yung radiogenic isotope, you're looking at radioactivity, heavy mineral survey, and polymetallic polynodule. These are specific metallurgical techniques, or at least geometallurgical techniques for doing these surveys. We won't go deeper into those kasi medyo mas higher siya level. Okay, so now let's go to, maybe you're wondering, minsan napagpapalit ko yung term na prospecting and exploration. Like in this case, geophysical methods, I always say geophysical methods of prospecting and exploration. Pero is there really a distinction between the two? And the answer is yes, okay? In the case of geochemical and geophysical prospecting and exploration, both kasi sila ginagamit sa both. Yung mga methods na i-report ninyo and this topic, yung pakita ko lang sa inyo na list, yun ay pwedeng gamitin for both prospecting and exploration. But how do you distinguish the two stages of mining? Number one of the biggest things that you should see or at least observe is the local. Kapag paliit na ng paliit yung area, okay, hindi siya palaki ng palaki, paliit ng paliit kasi you're being more specific on where to look for. Okay, these are clues already that you're going to exploration. And another thing is you're looking into the subsurface. Okay, kapag mas palalim ng palalim at paliit ng paliit, palilim ng palalim, paliit ng paliit yung area pero palalim ng palalim yung depth, that is more of going or shifting towards the exploration stage. Next, another is physical samples. Remember the meaning of indirect to direct methods. Ito ay, pag sabing indirect, ito yung under indirect, yung geophysical and geochemical. Okay? Pag sinabing direct, ito yung tinitingnan mo na yung mismong sample or at least kumukuha ka na nung mismong sample nung ore at dadali mo na siya sa laboratory para i-analyze yung content, no? So, yon. That's another thing. And another clue, which we will be discussing in the next few minutes or at least maybe next meeting, is the drilling. Kapag nagdi-drill na kayo ng madami at mas marami na kayong kinukuhang samples, okay, balik tayo sa sampling, no? That means you're already going to exploration stage. And finally, if you're getting more data, this is interesting, no? Lumiliit yung area pero dumadami yung data. At kung yung data nyo ay mas nagiging precise, mas nagiging specific, at mas nagiging certain kayo, then that would indicate that you're going towards exploration. Okay? There are certain categories then of the level of what you call, i-preview ko na to, no? We categorize ore bodies as mineral resource, okay, or mineral reserves, or ore reserves, also known as ore reserves. So, I'm just giving that out, pero in the next few meetings, paano natin i-describe ba yung mga ano na yun? Ano kaya ibig sabihin nung sinabi ko na yun? So, something to look forward to, at least. Okay, this is another explanation of what I just said. Phase 1 to phase 4, tapos decision. As you're here, sa mga regional appraisal, reconnaissance, ibig sabihin parang general scouting of the area, these are more of prospecting activities. Tapos pagdating dito, mas targeted, mas tactical, mas detailed, okay? These are more of exploration stages. And this is after, in our reference, Hartman. Okay? So that's it for that part. Do you have questions? Sobrang short lang ng geochemical, no? Yung geophysical, again, it's up to you. You have to learn about geophysical by doing your reports and afterwards viewing and at least evaluating what your classmates and batchmates will be making for the different geophysical methods. No need to be very technical about it kasi you have 10 minutes lang, oh, no? So as long as madali siyang magets, okay, try to do that. Okay, do you have questions? If you have questions, please put it in the chat or yeah, we will discuss the questions later after this part naman. So now we go to sampling. Okay, I've mentioned sampling for so many times, no? But let's go deeper into sampling. In the beginning of the session, I asked you what do you think sampling is, and at least what sampling is for. Okay, and I mentioned one na at least medyo na-hit niya yung hinahanap kong definition, no? Though all are similar. It's obtaining objective and reliable information on a population, or at least getting as a representative of a certain population. Why do we do sampling? Kasi we cannot get all of the things that we want to analyze or we want to study. For example, medyo ibang field ito, no? Pero halimbawa, sa PSA, Philippine Statistics Authority, if you want to know the number of the people in the Philippines, the demographics, etc., you cannot always do a census. When you say census, ito yung bibilangin talaga lahat. Yung mga nagbabahay-bahay, yung may sticker sa bahay ninyo, hindi ko alam kung aware kayo dun. Yung tinatanong talaga nila lahat ng information. So yun yung alternative to sampling. But they cannot do that regularly. So every 4 years or every so many years lang nila ginagawa yun. Okay? So imagine, paano pa kapag lupa ang pinag-uusapan, hindi nyo pwedeng bungkalin yung buong ore body. Tapos, okay, na-analyze na natin, balik na natin ulit. Saka natin miminahin. So you do sampling. That's why we do sampling, no? And one of the usual methods for sampling in the mineral industry is actually drilling. We will discuss more of that and also the other sampling methods in the next set of slides. So sampling is a mechanical function, okay? And it depends on so many things, okay? Ang sampling ay napakaraming parameters, okay? Ang daming fina-follow na standards, okay? By the way, if you want to look for the standards for sampling, you might want to check references such as the ASTM, the American Standards for Testing, and ano nga yun? Kalimutan ko yung meaning ng M. But anyways, meron tayong mga bodies all around the world, international and local standards on how to do sampling. And when you get to your, for those who are EM and MET-E here, when you get to your MET-E subjects, there are classes wherein you really do have to do sampling properly. Kasi kapag hindi, at lalo na sa thesis or lalo na sa ano ninyo, when you do research, hindi gaganda yung, papangit talaga, in other words, yung inyong results, okay? So sampling is very important. So all of these are the functions where, sampling depends on all of these and even more, okay? The method, the accessibility, the geology objectives of the project, statistical analysis, okay? And then when you say sampling pattern, the sampling pattern that you do, okay, depende, ano bang gagawin nyo? Every 1 meter ba? Tapos square ba yung pattern or whatever? This will be dependent on the nature and geometry of the ore body. Kasi may mga ore body na, you will see later on, na merong ore bodies na kapag, dahil kakaiba yung shapes niya at maaring iba-iba, like disseminated, no? Hindi siya isang buo. Kapag nakuha mo yung, nag-drill ka or kumuha ka ng sample, maaaring hindi siya mahihit nung sample na yon. Kasi, halimbawa, nakatabingi pala yung ore body, tas manipis na vein. Tapos dito kayo nag-sample. So, maaaring hindi nyo talaga siya mahihit. So, you have to do many patterns of sampling to make sure that you at least hit that area that you want to study. Okay? Now, some of the common, or at least low-tech sampling equipment are these. So hammer and chisel, okay? Ginagamit din ng mga paleontologists yan, and geologists especially. Spades, shovels, and mechanized loaders, okay? When you're getting a lot more samples. By the way, did you know the difference between a shovel and a spade? A shovel has a pointy tip and a spade has a rectangular shape. So if you don't know that, now you know. So kapag pumunta kayong Ace Hardware or wherever, handyman, sabihin nyo, ay, alam ko to, this is a spade and this is a shovel. Diba ang saya? Pero alam nyo, ang daming students na, like, first time nila nalalaman yan here in this class. So, okay, now you know. Okay, so, never mind. So next moving on. So where is sampling done? Sampling is done in so many parts of or stages of mining, or even outside of mining, in the fields of metallurgical engineering and geology and so many fields, sampling is done there. Pero in the context of mining, no, in the mining industry, number one, it's used to detect if something is there, valuable minerals are there. It's also used to determine how much there is and what's the possible grade, what's the concentration of the materials that you are trying to look for. So that's another reason why you do sampling, especially pagdating sa exploration stage. And then you're determining the grade and distribution of ore in a mineral deposit. How much, actually similar lang to, no? Almost, pero ito more on dun sa prospecting stage, ito yung sa exploration stage. And then mine valuation, if you want to know now, how much value can I get from the entire project? Okay. Magkano ang kikitain basically? Magkano ang yun, ipasok nyo na din doon yung ano no, expenses. So kapag gumastos ba ako ng ganito, makakabawi ba ako, magkakaroon ba ako ng profit? Ganyan. So yun, malaking factor ang sampling doon. And the accuracy, no? And then grade control then, when you're already operating the mine, sometimes you want to know, or not sometimes, more often than not, or always, you want to know na may maintain ba yung grade nung dun sa nakita ninyo sa exploration and prospecting stage yung nakukuha nyo ba, yung namimina na, is the same. Kapag hindi, ibig sabihin something is wrong. Maybe you're mining at a different area that you're not supposed to mine, or maybe masyadong mataas ang dilution. When you say dilution, nadadilute basically, nahahaluan ng normal na bato or some other rock yung namimina ninyo. And then, when you want to make sure of the final grade in the processing plant, isipin niyo, no, pagdating pa lang sa stage na bago magmina, nagsasample na. During mining or exploitation stage or production stage, nagsasample. Pati sa processing, nagsasample. Okay? Kasi you want to check talaga to verify na you're getting what you want to get. Okay? Now, let's go to the sampling stages. There are just a few basic steps. Okay? There are just 3 basic steps for sampling. Of course, number 1 is collection. You want to know what to collect, how much to collect, and how to do it. And then you should know how to prepare the samples after getting it. What processes are you going to do with that? What laboratory tests are you going to do? Okay, so dito na rin papasok yung sample testing, no? Afterwards. Okay, so yung sample prep before testing yon. So halimbawa, kailangan nyo palang durugin. Well, more often than not yung bato, dahil hindi nyo siya pwedeng ilagay lang dun sa machine na as a rock. You have to usually pulverize it or at least lagyan nyo ng reagents. There are so many different analysis, no? Different processes on how you can test the material. So maybe you learn some of that, or you have already learned some of that in the field of mining. Okay, now let's go to the methods. Okay, one of the simplest methods of sampling is actually grab sampling. You're just gonna grab it, literally. Like, kunin nyo lang yung sample or i-bag nyo lang siya, that's already grab sampling. It's done at any stage of exploration and more often during production stage. It's a very quick approximation, and dahil ganun siya kabara-bara at random, hindi siya accurate, okay? Hindi rin siya precise na method of sampling, okay? So yun. And as much as possible, we stay away from this unless wala na kayo ibang option, no? So, grab sampling. Okay. This is an example of a repository of drill cores, or tinatawag nilang core house, no? Pag nasa mine ka, nasa mine project ka, or nasa mining site ka, they have this. It's like a warehouse full of drill core samples. Okay, one of the most important or most common methods of, and most important nga in mining, as I mentioned earlier, is drilling. Okay, kaya ako pinakita ito kasi for the next set of slides, we will be talking about drilling. Okay, ito yung itsura niya ng mga drill core samples. It can range from lighter kinds of rock to durug-durug, pwedeng buo rin. Actually, depende talaga siya sa bato. Kasi kapag halimbawa durug-durug talaga, minsan nga maputik pa yan. So, minsan buhangin talaga yung nakukuha. So, normal yun, no? At lahat yun ay nililabel, lahat yun ay minamark, lahat yun ay kinikip ang records. More on this, on how we keep records of that. By the way, ito, look at this sample. Meron agad silang na-hit na mga metallic parts. I'm not sure if that's gold or maybe pyrite, either of the two. Ayan. So may coin to, anong tawag dito? For scale. Okay. So drilling techniques. So punta na nga tayo sa drilling. You have 3 major categorizations of drilling. You have percussive, you have rotary, and you have auger drilling. Okay. Sorry, not auger. Combined percussive and rotary. Yung auger and diamond drilling and its variations, under siya ng rotary. Now, these 3, how do you know the distinction? So I have here a Pringles can, or fake Pringles can. Hindi kasi siya Pringles, potato time. Anyways, so when you say percussive, ayan, nawawala yung video, pababa. Ayan, percussive. So parang dinidikdik yung sample, no? Tapos kapag rotary, umiikot siya. So, umiikot. And then percussive and rotary, obviously, umiikot na siya, tapos nag-up and down motion pa siya. So those are the different major categorizations of drilling. Under rotary nga, yung auger and diamond drilling. I-discuss natin to, at pati yung jackhammer and wagon drills under combined, we will discuss those sub methods. So punta muna tayo sa percussion drilling. when you say percussion drilling, it's also known as a churn drill. Okay? You usually have a chisel bit, yung dulo nung inyong drill. Nakahang siya sa cable. There's a picture in a while wherein there's percussive motion na usually nakakonect siya sa motor. When you say winch, it's the motor, or at least the mechanical source of the movement na pinapower ng compressed air, pwede ring manual or electrically driven. Okay? Tapos, yung churn drill usually gumagamit ng water, okay? Para maging muddy and slurry in a way yung iyong sample. Kasi kapag dry, sobrang intense nung heat and madalas nasisira yung yung chisel bit, no? So you use some kind of lubricant in a way, so water would serve as that in this case. And usually this method is for soft and medium formations lang. Pang maikli, 10 to 50 meters. Parang ang haba na ng 10 to 50 meters, no? Pero relatively maikli pa yan. At isa siya sa pinaka-cheapest methods, okay? Pero napakataas ng kanyang chance of contamination. Hindi siya precise and hindi rin masyadong accurate yung kanyang itong method na to, no? And it's kind of inefficient to demarcate or body contacts. Hindi mo ma-determine yung hangganan or at least the extent and even the grade of the samples that you're looking at. Maraming contamination. So ito yung itsura niya, no? So meron kang power unit or yung winch, tapos naka-connect siya sa pulley, tapos ito yung drill bit pababa. Okay? Tapos may pump, okay? Pump can do two things. Pwedeng tanggalin niya yung water, okay? Or in some cases, you want to put water to serve as lubricant. Okay? Next, under rotary, okay, the first subcategorization of rotary is auger drilling. So ang auger ay yung shape na parang spiral, okay? This is limited use, usually sa soil or soft and loose ground siya. Kasi makikita niyo yung itsura mamaya ng auger, mahirap siya i-imagine na magdidrill kayo ng auger sa bato. Okay? Another low-cost method, it's quite fast. It can be hand or mechanically powered. It's usually used for quick estimations. And dahil low-cost nga siya and fast method, usually it's also inaccurate. Okay? Ito yung lengths niya. Kapag hand-operated, up to 3 meters. Kasi ang lalim na ng 3 meters, no? Lampas tao na. So, ang hirap na i-hand operate nun. So, 10 to 15 centimeter diameters. And then, mechanically driven can reach more than 30 meters. So, ito yung tsura ng auger. Particularly hand auger. Para siyang, alam niyo yung corkscrew, no? Parang malalim na, malaking corkscrew, ganon. So, there are auger drills na meron, hindi ko pala nalagay yung picture dito, no? But I can show it to you maybe, I think, pagdating pala kay Ma'am Cheska, I think yon may auger drilling kasi na tinatawag. Augers can also be used as a method for drilling. So I think she will discuss that to you. So this word means, unahan ko na kayo, this means width, okay? So for those who don't know, another thing na some people are laughing about, I don't know why. Percussive cum rotary, di ba? Yung parang cum laude with honors. Cum. Yeah. Okay. Yung percussive with rotary or cum rotary, ito yung both yung movement, no, up and down and rotating. So these are usually air-driven or air-powered drills, hydraulics or sometimes hydraulic powered. It's limited to 6 meters most of the time. So mababaw siya, no? And then water is injected through hollow steel rods to cool the bit, okay? And then the return water flushes out the crushed material. And this is usually used in tunnels, advancing mine phases, and breaking big boulders. Pag sinabing advanced mining phases, for example, you have an opening underground. Ito halimbawa, ito yung itsura ng opening, tapos yung tao ganyan lang kaliit. So, di ba may papasok siya, pero pagdating niya dito, hindi pa siya na-excavate kasi nakaharang siya. Yun yung phase. Ito yung tinatawag na mining phase. So, kapag parang dead end, ganun. So, kapag nag-advance kayo ng phase, you can use drills such as percussive cum rotary. Ano ba yung mga under nitong percussive cum rotary? I think you're more familiar with the term jackhammer. It's under this method. Okay? So this is limited use in mineral exploration, more on getting a few samples, or at least in construction. Yeah, like sinabi ko nga, jackhammers and wagon drills. So the difference lang between the two is yung isa handheld, yung jackhammer, yung wagon drill, meron siyang attachment. Okay. Okay. One of the most important, diba sabi ko, one of the most significant methods of sampling is drilling. But one of the most important methods of drilling naman is diamond drilling, okay? Which falls under rotary method, okay? Ang diamond drill, kaya from the word itself, ay gumagamit siya ng diamond. Kasi if I don't know if you're aware, but diamond is possibly one of the hardest, okay, minerals and hardest substances we have on Earth. So that's why we use it to drill. It's used very extensively in mineral exploration, but it can also be done in so many things: dam sites, other foundation test works, mine development phase, drainage of mine workings, mine ventilation, oil structure, oil, gas wells, etc. I just remembered, I don't know if you've seen this, ang tagal na pala ng movie na to, no? Yung The Day After Tomorrow. Kumukuha sila ng, yung opening ng movie na yun, kumukuha sila ng drill core samples or nagda-diamond drill sila sa ice. Biologists would also use that. Bakit nagdi-drill sa ice? Or kung nanonood kayo ng National Geographic, no? Nagdi-drill sila ng ice kasi may mga trap na pockets of air, and it would give you clue on how, doon nila nalaman actually, isa yun sa biggest evidences na bakit nagkakaroon ng rising carbon dioxide levels sa atmosphere. That's how they knew it. So they're getting samples from the ice and glaciers. Napansin nila noon, hindi naman ganun kataas yung carbon dioxide content, and ngayon sobrang taas na. So that's another application of diamond drilling. So balik tayo sa diamond drilling in the mining industry. Again, it can be powered by diesel, pwede ring electric, pwedeng compressed air, okay? At kaya niya ang malalim na na holes up to more than 2 kilometers deep, kaya, okay? At kaya siya ng minimal ang crew, 2 to 3 people, and definitely may geologists dyan most often than not, and even mining engineers, no, pagdating sa perspective and exploration. And then when you say drill rods, ito yung nagdi-drill. Ito yung mismong kumukuha nung rock samples na cylindrical core samples. Kanina I also mentioned drill core. Drill core is usually the ang tawag dito yung sample na cylindrical na mahaba. So yun ibig sabihin nun. Okay? Usually 10 feet ang drill rods, tapos naglalagay din ng water para ma-flush or at least ma-cool yung bit. Kasi imagine yung friction ng diamond, no, sa dulo ng bit dun sa bato. And these are the diamonds that I was pertaining to. Don't look for diamonds na kumikinang, hindi siya makikita in this case, no? Ito siya. At hindi siya yung diamond na shiny and I'm looking for a word, adamantine, or hindi siya lustrous. These are diamonds that are industrial grade. So ito yung mga nasa dulo na yan. Those are diamonds, at yan yung diamond core bit na tinatawag. And ito yung main na cutting tool, nasa dulo siya nung drill rods mo. Okay? And what else? Okay, let us go here. Okay, these are other figures on core drilling, diamond core drilling. So nandito yung diamond drill bit, tapos umiikot to, and then kumukuha ka ng sample nasa loob, okay, nung drill pipe or nung barrel, yung iyong core sample. And then ito pala another view of diamond drill bits. Ayan, ito irregular. Tapos ito yung medyo mas may pattern siya, pero diamond pa rin yan. And then this is what you do with the core sample that you get. You usually divide it in half or 1/4, kasi yung kalahati niyan, pag half lang, kalahati ay i-analyze, kalahati ay ikikipang record sa yung pinakita ko kanina, yung warehouse, yung sa core house, tinatago doon. Or pwede rin quarter, no? Ayan. Okay, so this is how it looks like, a setup of a diamond drill looks like. Okay, so you have the motor, you have the pump for water, you have the drill head, you have some of these parts are kind of we don't really need to emphasize, but at least you have an idea on how it looks like. Okay. Sometimes instead of this tripod setup, meron siyang naka-attach sa truck. Okay. In some cases, naka-attach sa truck. And drill mud is one of the most common lubricants used aside from water. If you would remember the minerals bentonite and barite, I mentioned this last time. Industrial minerals ito, napakaraming gamit niya. No? Isa sa pinaka-common na gamit ng bentonite and barite, it's used to as lubricant for this purpose. Okay? Para malesen yung friction, malesen yung heat, at mas easier no? Mas madali yung inyong pagdidrill. Okay? So other things in diamond drilling, when you say core barrel, it is attached between the lower end of the drill rods and the reamer shell. It holds the core inside while drilling and brought to the surface. So balik tayo sa diagram kanina, yung core barrel, siya yung parang inner cylinder. Meron kang outer cylinder, okay? Meron kang inner cylinder, at yung naglalaman nung core itself, that one is the core barrel. Okay, na itong describe ko dito. There are other kinds of it. There's single tube, double tube, and triple tube. Isahin ko na lang yung description. Basically, the more tubes there are, the more layers of tubes, it's for samples that are more crushed. Okay? Pag single tube, ginagamit siya for best recovery conditions. Ibig sabihin, buo yung makukuha mo. Kapag the more unconsolidated rather, the materials are the more broken, friable, and sheared formations, the more you go to triple tube. May nagtanong sa akin sa class, and nagtanong ako sa class before din, sa face-to-face. Sabi ko, ano yung friable? Tapos meron doon, naalala ko lang, nag-gesture siya ng ganyan, no? Parang nagpiprito daw. Tapos, no, that's not friable. When you say friable, okay, friable means madaling madurog, okay? Madaling maggutay-gutay. We will be using this term in many cases. Friable means madali nga siya madurog or madaling maggutay-gutay yung material. So you use triple tube for those cases. Okay? So this is a double tube and this is a triple tube, for example. These are just examples, no? Okay. And then these are the common sizes of diamond drills. Okay? Naalala ko lang, yung mga EM dito sa class, if you are, try to remember this. Before, they used to ask this in the board exams. You have to, at least, lalo na kapag kapag nag-work ka sa siguro mamememorize mo to by heart. Ako nakalimutan ko na siya, to be honest. Pero nung nag-board exam ako, I memorized this by heart. And madali lang naman, may pattern. Yung sizes, and the usual drill samples or drill sizes that you do. Okay? Yeah. Diameters. Okay, and then next, let's have wireline drilling. Okay, wireline drilling naman. Okay, from the word itself, wire. Okay, may wire. Meron siyang wire, pero nasan yung wire? Okay, this method is used for withdrawing the core and inner tube assembly or the whole core barrel without pulling out the hollow drill rods. Okay, it can save you considerable time and energy. Ito pakibasa na lang on your own, no? Ganito siya. In a simple manner, old methods of diamond drilling would actually have the whole, I would say plethora, the whole attachment or the whole thing drilling. Tapos, if you have to get the drill core sample already, the rock sample na cylindrical, you would have to remove everything. You have to pull everything out. Okay? Para lang makuha ulit yung tas babalik mo ulit, kukunin mo ulit, babalik. So, it's tedious and it wastes a lot of time. Nung na-invento nila, na-develop nila itong wireline drilling, yan, ang kita nyo may wireline, yung wireline na ito, hinihila niya na lang yung part na kailangan ninyo makuha. Kasi syempre, di ba, habang nag-excavate, tuloy-tuloy ang excavation, tuloy-tuloy ang pagdidrill ng diamond bit ninyo, drill bit, and then the samples, you can easily pull it out using the wireline method. Yun lang ang basic difference nung conventional sa wireline. And I hope it's easy for you to remember. There's another variation aside from wireline, or pwede ring combined with wireline, is what you call continuous core drilling. Okay? it works on the principle of reverse circulation, RC. Ano yung nagsisirculate? So you have circulating air down to the bit head outside the drill rods and you return it up inside the bit, core, barrel, and drill rod. So may nagsisirculate na air. Okay, the effect of reverse circulating air is to continuously float the core back to the surface. Okay, so I think this is easier to remember if you would see how it looks like. Okay, here it is. Ayan. Look at here. So you have air inlet and then you have that air pumped out and that the samples are deposited here. Reverse circulation siya kasi the direction is pababa tapos sa dulo, doon siya papasok sa dulo, tapos pabalik. Kaya siya reverse circulation. Kasi counterintuitive no, inisip nyo parang pa ganun. Eh di mas pupunta lang sa ilalim. Gusto nyo kasi paakyatin yung material. And if you notice, this is commonly done for those samples that are very unconsolidated, like yung durug-durug talaga. Okay. And usually yung sample chamber, minsan ginagawa nila siyang conveyor belt para makita nyo bakit hindi lang isang pail or isang imbakan kasi edi naghalo-halo na yung samples. So kapag conveyor belt kasi, at least you know, itong unang nakuha, most likely mas malalim or mas mababaw. Tapos habang nagmo-move yung conveyor, tuloy-tuloy siya yung pag-dump niya ng samples. So at least you know which ones are deeper and which ones are shallower. So yun yung RC, reverse circulation drilling kasi may circulating air. Okay? What else? Yes. In this case, ito lang yung mga common uses niya for iron ore, bauxite, limestone, rock phosphate, and coal seams. Anong common sa mga to? Lahat ito ay relatively soft, relatively friable, and unconsolidated. And then, ito yung specs niya lang, no? 10 to 15 centimeters large diameter, high speed, and low cost. By the way, if you're wondering, when you study for your quizzes or long quizzes in this course, no need to memorize. I'm just pointing out the pero no need to memorize those specs, okay? And then advantages, kaya niya yung mga hardest formations. Kasi yung hardest formations, kahit madurog siya, okay lang, kaya ng RC drilling. This very, very short video, and maybe, I think patapos na rin tayo ng konti, no? On the difference between diamond drilling versus RC drilling. So let's watch this. Let me just share the sound.
Prior to the initiation of exploration operations, geologists often wonder what method of exploration drilling is the most effective and at the same time the least expensive. Core drilling, RC drilling, or a combination of these two methods. To help you make the right choice, Niet Berga Company offers an overview of the characteristics of each type of drilling.
Advertisement siya technically, pero it explains both.
Core drilling, or also called diamond drilling, is a type of fast rotation drilling, the implementation of which results in the destruction of the rock within a ring pattern, but not over the entire bottom hole. In this mode of drilling, the interior of the rock, in the form of core, a rock pile with an undisturbed structure, is fully preserved. For this purpose, the core is periodically locked and isolated from the bottom and lifted up to the surface using a core receiver suspended on a rope from which the core is removed and distributed to core boxes. RC drilling, or also called reverse circulation drilling, is carried out using the air supplied through the rods with a reciprocating piston, a so-called air hammer, used as the drilling mechanism rotating the drilling bit made of tungsten steel. When pressure is applied to the rod, an aerodynamic lift is generated by means of which the water rises up the annular space with the sludge rising within the inner tube, which is located inside each rod. Ideally, in the course of RC drilling, we obtain dry drill cuttings, since the compressed air from the compressor dries rock in front of the drilling bit. The cuttings reach the reflector on the rig mast, move through the sampling hose, and into the cyclone, followed by processing within the cyclone until released through the opening at the bottom, whereupon collected in a sampling bag. For comparison, during the drilling method with direct blowing, which is mainly used for the blast hole drilling cuttings, reach the Earth's surface using the same air pressure, but through the annulus, where the sample is naturally contaminated. The most commonly used drilling bits for RC drilling have a diameter of 124 to 130 millimeters, with protruding round metal buttons or pins. If we use in diamond drilling the average size of 95 millimeters, the core diameter is about 63 millimeters. Thus, comparing RC drilling and core drilling by the sample amount, RC drilling is characterized by the obvious superiority. It is also worth noting that unlike air hammer drilling, core drilling provides geologists with the opportunity to visually analyze samples, since an undisturbed core structure provides a complete picture of the structure and rock occurrence. When exploring at shallow depths, RC drilling can be used independently without the aid of core drilling. When exploring to a greater depth, RC method is used as a cost-saving method of drilling in order to reach mineralization. After that, geologists may decide whether to continue RC drilling to extract cuttings or go shift to core drilling for the extraction of the core. In this case, RC drilling becomes a great addition to the normal core drilling. Due to a number of the factors mentioned above, RC drilling method is cheaper than core drilling, and therefore it is preferred in the exploration of mineral resources. The choice of method used in the exploration and assessment work depends on whether drilling is performed from the surface or from mines, on the geological features of the deposit, hole depth, the complexity and the category of drillability of rocks, as well as preferences of the geologist. Modern coring rigs allow for fast and efficient coring to a sufficient depth from holes of different diameters. At the same time, RC drilling has become so progressive and advanced that more and more geologists believe that to determine the mineral composition of rocks, RC cuttings are enough. Taking all the aforesaid into consideration, we should say that drilling from the surface offers a choice of cuttings, core, or a combination thereof. Underground RC drilling is certainly technically possible, but until now has been used to a very limited extent.
Okay, so more on cuttings and core in the next sets of slides. Pero basically, kapag core, buo siya. Kapag cuttings, yun yung durug-durug. Yun lang yung ibig nung sabihin. Cuttings versus core. Okay? So ito yung sinasabi ko, no, na naka-attach siya sa likod ng truck, yung itsura ng drill. So this one is actually RC drill ito. And another thing that I don't know if you noticed, ang diamond core drilling ay rotary, ang tawag dito, RC drilling, meron siyang action na rotary, pero meron din siyang percussive. So percussive cone rotary. Okay, so ito yung sinasabi ko. Ayan, hindi ko alam bakit may hindi lumabas na ano. So, kapag core, yun nga isang buo. Tapos yung cuttings, yun yung either dry or wet from the word itself. Kapag dry, ano siya, tuyo. Tapos kapag wet, may tubig. So, ito yung mga types ng drills na makakakuha kayo ng dry cuttings like air flush diamond, rotary auger, or percussion drilling. Kapag sludge siya or wet, maaring galing sa churn drill, diamond drill, or wet rotary or percussion drilling. And then, na-mention ko na to, itong in-skip ko na yan, kasi usually kalahati or hinahati yung core sample, some parts of it are analyzed and the others are preserved for future use or future references. Okay, I think we will end with that muna for this session. So, let me stop sharing. If you have questions, again, you may